Hi, and thanks for tuning in to the CBA Podcast, a place where we chat about our own recent achievements in the area of electronics, software and mechanical engineering, and more likely than not, give excuses for not having done anything at all. This time we'll talk about PCB layout for my CPU project, making light pipes and bendable zones out of acrylic, the flashing light price 2018, the A-276 Hell sensor motor driver, and fixing retro gear. So I said we, but it's basically just gonna be me. Piotr might be back at some point, but I'm not sure when. So let's just continue with a solo episode and a solo podcast for now. I'm just gonna tell a few things what I did last couple of days, last week, and one of those things is making a few redesigns, relayouts of plugin modules for my CPU project. Now I talked about this a few times earlier. Yeah, what I did was relayout 3 boards. That's the latch board containing a number of 1-bit latches, D latches, a multiplexer board, and an increment board. It's not very spectacular, but as I said last time, the changes are basically, it's a bit smaller, each board is a bit smaller, and the components are grouped logically into shapes, so you can actually see which components comprise a multiplexer, for example. And also there are some LEDs on the front, so you can actually see the bits as they move through the module. So that might be interesting. I hope some or all of it works. It's not a very big deal. I used the open collector LED driver to control the LED, so I hope that works. I didn't test anything, but you know, how difficult can it be? So that's what I did. After this is done, I need to do one more board, one I/O board, and then the base board with some intelligence on it. And then all the PCBs are done, and I can start making an enclosure. Now for that enclosure, I'm planning to have a LED matrix at a 45-degree angle to the user, so it's at 45 degrees to the PCB. The LEDs are on the horizontal surface on the PCB, and I would like to show the LED matrix at an angle using light pipes cut out of acrylic. So I'm toying a little bit with that, see what works, see what doesn't, see what is mechanically stable or not, so it shouldn't break in your hands, and see how much light will bleed out of the sides, for instance, and how sharp an angle you can make, and so on and so on. But that seems to work quite nicely. Also, some other thing I did was test laser cutting acrylic to make a bendable zone. So you have a long strip of acrylic, and in the middle, for example, you make a mesh shape. I think I talked about this last time as well. So you can bend it into an angle. And I tested a little bit with the width of that zone, and depending on how wide that zone is or what shape you use to cut out the mesh in that zone, you can bend it into 45 degrees or 90 degrees or even 180 degrees, no problem. So that worked quite well. I can post a picture of that, maybe it's interesting. I didn't come up with a shape myself, just stole it off the internet somewhere, but what I saw, and after talking with somebody else, that's pretty much what everyone uses, I think. So that works out quite well. Another thing I did was complete waste of time, but it was quite fun to make an entry for the Flashing Light Prize 2018. Now that is a competition, online competition. I think it ends in March. I'm not really sure. I'll post the URL. The idea was to make a neon bulb flash at 1 Hz with a duty cycle of 50%. Now you can, and the rest is up to you. So you get points, for example, or points you get, you know, and they look at how creative a solution is or how pretty it looks or how much work went into it and so on, how original it is. So what I did was, I didn't want to spend too much time on this, so last time I made something that was just made in 10 minutes one morning when it seemed like a good idea to compete. This time I want to do something similar, so minimal effort, maximum result. So a neon bulb or neon light is already sitting in the switch of my power strip. That happens to be a neon light. So what I did was put a power strip on the table, make some kind of pendulum using a weight from a dumbbell to weigh it down to give it some mass. Pendulum swings to the left and right. Every time it swings to the right, the button goes off. Every time it swings to the left, the button goes on. So when the button is on, the power strip is powered on, obviously. Then I connected a motor to the power strip, and every time the button goes on, the power strip goes on, the motor pulls the pendulum to the off position. When the pendulum is in the off position, it swings back to the other side, the switch goes on, motor is activated, and so on and so on. It's not perfect, it's not exactly 1 Hz, it's not exactly 50% duty cycle, but who cares, it works. So I was quite happy about that, and posted the result on YouTube, and let's see how it goes. I don't actually care if I win anything, it's just for fun. So I'm happy to see all the other projects, and I think there's 6 entries at this time of writing, but there are probably gonna be 20 or 30 or something like that, if it's anything like last year. So that was quite fun. That motor that I used for that was, I blew up one motor in the process because the motor doesn't like being powered on when you stop it. So one burned through, and I opened it up, and it was a brushless DC motor with 4 coils, or 2 coil pairs. And there was only one component inside, and that was quite surprising to me. I never saw that, so looked up what it was. It was an A-276 Hell sensor and motor coil driver. So it's basically a small transistor shaped thing with 4 leads. So that's VCC, ground, open collector output 1 for coil pair 1, and open collector output 2 for coil pair 2. And there's a Smith trigger, like a hysteresis, so it switches one output on and the other off when north pole of the magnet approaches it, and it switches, it reverses the output when the other pole of the magnet approaches it. So that was quite interesting. I never saw that. Maybe old news, but it wasn't old news for me. So that was basically all. One more thing I did was fixing some old gears, or at least try to fix some old gears at that hobby retro computer place I might have talked earlier about. It was an awesome space in Utrecht. What I tried to do was fix an old keyboard with an LED backlight. That didn't work. I was not really in the mood, so I gave it an effort, an hour or something like that, and I tossed it aside because I was no longer interested. So then tried to fix a Atari VCS and found out there was nothing to fix. Everything worked, and then I made an AV adapter using a simple BC547. Bias the base and use it as an emitter driver or emitter follower to output a composite signal. So that was all, and after that destroyed it because it was a hack. I'll do it better next time, but I was getting a little bit bored. It was not the best fixing session, but it was okay. So that was all for now. For more information, links and previous episodes, visit podcast.cba.si. Stay tuned, thanks for listening, and goodbye.